PhD?
No.
In fact, you're presently a student. You're presently a student at the University of Denver seeking your PhD. Is that correct?
Correct.
Under the supervision of two other professors who are experts in the area of touch DNA, correct?
They are not experts on the touch DNA.
Oh, what is their area of expertise?
They're in the biology department.
Well, I mean, I assume that, but what is their area of expertise? They're your PhD advisors, right?
Yes.
What is their area of expertise?
Well, Dr. Phil Danielson does forensic DNA, and mitochondrial DNA, for instance.
And you're under their tutelage trying to earn your PhD?
Yes.
Your laboratory that you discussed, the one in Holland, the one that you became the director of, you and your wife started that, correct?
Correct.
Sort of a mom and pop situation, just the two of you. I'm sorry, that's an American expression. I'm probably. In other words, the two of you started it, and you were the entire company. The two of you.
No, actually, the IFS was started with my wife and a co-worker from the National Lab, and I joined in 2005.
Okay, so three of you. Okay, and your laboratory is actually in a converted barn. Is that correct? Correct.
Part. We bought a farm, and we rebuilt the farm.
And you converted and retrofitted it, the barn, in order to make it into a DNA lab. You have, secure facilities and all that kind of thing.
Yes, so we changed everything into a normal DNA facility, which is accredited as well.
Now, in 2008, approximately, you and your wife decided to expand your business to the United States, correct?
Yeah.
And this was a business decision because there's a great deal more work potential in the United States than there is in Holland, correct?
You have more homicides over here, yes.
And you would agree, would you not, that the exposure that your company, that hasn't started yet, will get in this case is going to be extremely helpful to the future of that business venture? Wouldn't you agree?
Well, I'm not so sure about that, but we already work in the United States, in more than 7 states, and we're very busy with cases, so we're not really waiting on cases. The cases have to wait till we are finished. Our turnover times are more than half a year. So, no, we don't really need a lot of more attention.
But your laboratory isn't even open yet, is it?
No, in the United States.
In the United States?
The cases which we work on in the United States, we still do that from the Netherlands.
Right. And when you open your laboratory in Colorado, in the United States, it would be really nice to have a lot of work, wouldn't it?
We already have a lot of work, so actually we're trying to downscale it a little bit.
Get him, Jeff.
And you're, the more work you get, obviously the more money you and your wife make on the new project, right? That's why you opened it.
Well, we're not really working always for the money. We have cases which we did for free, and so we rather work for in the way that we can work like we want to work. So we want to be able to work the way we want to do. And if we business-like, if we wanted to expand, we could have expanded way much more than we did now. But the problem is, it's very difficult to get good DNA scientists which can do this contact DNA, which we do a lot, in the way we want it. So we choose to be not too big.
Do you do something that's different than other laboratories? Let me extract that and ask another question. How many laboratories are there in the United States that do the same thing that you do?
I think it's growing now. I know that Bodhi Technology tries to do something about contact DNA. I know that the American New York laboratory started to do contact DNA, also use low copy number DNA, and also the laboratory in Denver is start using more sensitive methods like we use.
Now, Bodhi Laboratory, that's a large laboratory. That's not a laboratory in a barn. It's a large concern.
Yes.
So there are a number of laboratories in the United States that could do exactly the same thing that you do.
I don't agree. I think we have more experience than the other labs.
Explain to the jury what you mean by that. I mean,
well, with this contact DNA and touch DNA, objects which were worn by victims, what happened is that I think the first time we started with it in the Netherlands was 1997, and in 2000, the United Kingdom, or before 2000, but in 2000 we started research on low copy number DNA. The low copy number DNA means that you have the amplification, but you do more amplification cycles than the standard methods use. In the United States, this method was, well, actually not used, I think, till recently. In 2002, we validated the method, and in the national lab I was working on high-profile cases, and I used it in every case which I could not solve. So if we don't have DNA results, and very often then, if there was contact between a victim and a perpetrator, what you start doing is looking for contact DNA. But in order to do this contact DNA, you needed low copy number, especially in that time, to work more sensitive. Well, that didn't happen in the United States, and therefore, I think in the United States, the main state laboratories used mainly DNA from blood, saliva, or semen. But at that time, because I worked all these difficult crimes, we got a lot of experience with this contact DNA.
did you invent the protocol and process of low copy number DNA?
No.
Where was that invented?
I think the Forensic Science Society laboratory, which is currently closing, I think, but I think they started the experiments.
Where is that?
United Kingdom.
You use a particular, do you use a particular kit or protocol that you purchase from some location in order to do this low copy number DNA you're talking about?
Well, in principle, you can use every DNA kit because the method is only amplifying more than the standard number of amplification cycles. So you can do it with every kit. We use different kits, especially the last couple of years. Some new kits came on the market which are more sensitive.
And you buy those from Applied Biosystems Incorporated?
That's correct.
Which is an American company, correct?
That's correct.
Now, let's talk for a minute. You said you can do things other people can't. Explain. Let me strike that. The only thing you do extra is you run additional runs of the, let me start back again. PCR is the process of replication of DNA, correct?
Right.
Normally, you said, I think in one of your slides here, normally it's a run of 26 to 30 runs of this replication process.
20 to 30, yes.
Okay, 20. And the way that works is it takes, basically the first run takes one intact cell of DNA, one intact strand of DNA, and creates a copy, so it makes two.
Yes.
Right. Next run, 2 becomes 4. 4 becomes 8, 8 becomes 16,
Yes.
and beyond that my math skills fail me.
32, 120.
Right, exactly. So by doing this 20, 22, 25 times, you make hundreds of thousands of copies of this DNA.
Idealistically, of course.
That's a button part, sorry?
Idealistically, of course.
Idealistically, right.
The problem with forensic samples is very often they're not like in a hospital. They're more difficult. There's debris or dirt in there which can inhibit the reaction. So you have to take that into consideration. That's why I'll say they already laboratory were able to get a profile from one cell, but forensically that's not really realistic.
Right. So theoretically.